Hello everybody. So today we will discuss about per unit system. So this per unit system we actually use in a power system network where a lot of machines, that means alternators, transmission line and loads, they are interconnected, and transformers, they all are interconnected. So we have seen a problem in previous lectures that where they were solving a circuit where two transformers, one transmission line, one generator and one load was there, right? In solving that circuit, we have seen that we are requiring a lot of transformation from one end to the other end, either impedance or the voltages, right? So you can think of the situation where a lot of these components are available, these power system components are available, and then you are solving this circuit. So obviously it would be very tedious, and it doesn't give us the sense of relativity as well. That means, let's say if I talk about 0.1 ohms or 0.2 ohms of two machines, that this machine is having internal impedance of 0.2 ohms and even the other machine is having the internal impedance of 0.2 ohms. So it doesn't give us a relative picture, right? Because let's say 0.2 ohms for one machine would be for a machine would be a smaller quantity, and same magnitude of internal impedance might be big for some other machine, the current or the power, right? So how much losses are there in one machine? So let's say if somebody says 200 watt in one machine, so 200 watt in one machine and 200 watt in another machine doesn't mean that both of them would be having the same efficiency, unless and until I know the per unit quantity of it. Okay, let's say if I say that there is a loss of 10% in one machine, in another machine also there is a loss of 10%, then that makes a sense that the chances are that both of the machine is having the efficiency of 90%, right? So by using the SI unit for the calculations in a large network, we cannot define, we cannot comment on the relative parameters. So that's why this per unit system was introduced, and this system itself removes the so many conversion or transformation from one the transfer of the voltage or impedance from one side to the other side. It inherently is having that feature. Okay, so that is one of the advantages of using per unit system, and it gives the relative picture as well. Okay, so what is this per unit system is actually we define a unit, that this per unit either for voltage, current, power, impedance, etc. Okay, so per unit of voltage per unit, current per unit, power per unit. Okay, this is defined as actual value. So this can be anything: voltage, current, power, let's say in VA or watt. So I will write in VA, or the impedance, that is in ohms, actual value, and then you have to choose a base value. Okay, and we'll see how to choose a base value. We'll discuss it, and the base value for the same quantities: voltage, current, power, and the impedance or the admittance as well. Okay, so we need to in a network where a lot of components are connected, a lot of machines, alternators, transmission line, transformers, they are connected, then we have to choose let's say in different region, we have to actually define the base values. Okay, so we'll choose two base values, the voltage or the power. This is generally used, and then for the other regions we will actually calculate what would be the base values there. Okay, so once we know the base value there, we can easily compute what would be the per unit system. And we will take up a problem where we will convert the actual network into a per unit network, per unit system, and we will see the advantages of it. Okay. So we need to first choose the base value of the electrical unit, electrical quantities is chosen. Okay. So out of, let's say, voltage, power, current, impedance, let's say admittance as well, all those. So out of these, any two quantity we have to choose. So generally power engineers, they choose the power. Power means apparent power and the voltages. Okay. So let's say where multiple machines and multiple transformers are connected. So which voltage we should choose, which power we should choose. Generally we can choose any value, but the standard is we should choose the highest voltage available there. Okay. So it should be the highest voltage available in the network. Okay. So highest voltage available in the network you have to choose, and power the highest one. Okay. And for a particular machine, let's say for machine, alternator, or for transformer, let's say if we want to define the per unit quantities, then obviously the rated voltage, we would be defining that one. The rated voltage there would be the base voltage there. Okay. And the power rating of the power rating of the transformer would be the base power there. Okay, the apparent power. And let's say the apparent power in a transformer. So the apparent power in a transformer, either from the primary side or in the secondary side, they remain same, right? So in a network where you have connected multiple transformers, you can actually choose the apparent power. You can, once you know the apparent power of your transformer, the base value of that one, you can easily define what would be the power, per unit power of the transformer there. Okay. So we'll take up an example where this would be clarified better. So once you know the base value, any two base values, let's say we have defined the S base for the power, apparent power, and V base if I have defined for the voltage, then I can easily compute the I base, which would be S base upon V base. Okay. And what about Z base? So Z base means the impedance, base quantity of the impedance in that region. That would be that would be V base upon I base, because once I know the I base, I can calculate the Z base here. Or even you can calculate V base whole square upon S base. So once I know the base quantity, I can actually calculate the per unit quantity. So V per unit, voltage per unit would be V actual upon V base. Current per unit would be I actual upon I base. So I per unit means, if you can see the numerator on the right hand side is in ampere and denominator as well is in amperes, right? So it does not have any unit. That's why we say it per unit quantity. Similarly, Z per unit you can calculate, and that would be Z actual upon Z base. Okay. So now we'll take up an example and we'll solve that example, and we based on this per unit system, and this will actually clarify it will clarify our more doubts as well.